I'm a bit nervous up here, I must say. I feel a bit anxious, but that's nothing new. I've always felt anxious ever since I was a kid. I remember the first time I felt that anxiety. I was a young child in my parents' backyard, and I was staring up at the night sky. It was a cold winter's evening, and I was staring through the stars, and I felt this wave of anxiety roll over me. And that night, I couldn't sleep. I couldn't sleep for thinking of the sky, this unending sky with its million stars turning their planets everlastingly in this utter nothingness. And I took that feeling of anxiety with me through my studies in physics until I discovered a piece of artwork. This piece of artwork. Press the button. There we go. Awesome. This piece of artwork by David Goodsell, which depicts an E. coli bacteria, specifically the inner workings of that bacteria. It's very famous within our field. I decided to pursue this. So I looked at this piece of artwork for the first time, and I braced myself to feel that same anxiety I'd felt so many times beforehand. The level of complexity of all these moving parts, I expected to feel the same way I had when I looked up at the stars. So I braced myself, and I didn't. Instead, I felt this wave of calm roll over me instead. So I thought, okay, probably worth looking into a bit. So I did. I started looking into a field called biophysics, which is biology studied through the lens of a physicist. And I now work on this very bacteria, E. coli, looking at the information processes that are going on inside of that bacteria. But before I go on to my work a bit, I want to explain some of the takeaways I got as I studied biophysics and I started to understand where I got this feeling of calm from when looking at this piece of art. See, there is this concept in science, in physics, called entropy. Entropy is a measure of how chaotic, how disordered a system is. Let me give you an example. Imagine a teenager's bedroom. Before and after you have asked them 6 or 7 times to clear it up. Beforehand, it is a very disorganized room. Clothes are strewn this way and that. A physicist would call this a highly disordered state, a high entropy state. Then, after they finally moved all their clothes into the closet, hopefully neatly, this is now a very low entropy state. It's a state of very low disorder. Everything is far more organized. So this is what entropy is. Cells also have entropy, but unlike a teenager's bedroom, they cannot exist in a high entropy state. They would die if this is the case. High entropy for a cell means that it can no longer function. This is death. So how do cells go about dealing with this? How do they go about with this idea of a high entropy state? Well, they harness entropy in a very interesting way. Let me give you an example. Imagine you are consuming some nutrient, for example, a bitterball. You eat it, and the nutrients go through your blood, and they enter all of the different cells. The nutrients are dispersed throughout your body, and in this way, they increase the entropy of the nutrients massively. But this allows the cells to keep their entropy low and stable, allow them to continue to remain organized in this low entropy state. And this is the point. Cells are the masters of their chaos, not by trying to control it, but by accepting its inevitability. And I think that is absolutely beautiful. So I'll now describe another point that I was talking about earlier, this concept of information. Information is a measure of how surprising a result is, fundamentally. Let me give you an example. Let's go back to the teenager's bedroom again. And this time, the teenager is asking you questions about where their favorite shirt is in amongst their bedroom. Now, let's take the example of this low entropy bedroom state, the one where he's cleaned up all these things. Now, if he then starts asking you questions about where the shirt is amongst the bedroom, and you tell him, well, obviously it's on the left, it's in the closet where the clothes are all organized, because it's in this organized state. This question and answer pair gives you very little information. It's not a very surprising result to tell you. However, if instead the teenager has not cleaned their bedroom, then the question and answer pair again happens. Where is my shirt? Well, it's on the left-hand side. But now, the shirt could have been anywhere in the room. So telling this person that the shirt is on the left-hand side is a far more surprising result. See, there is this link between entropy and information. So if cells harness entropy, then it makes sense that they also care about information. And that is precisely what my PhD is focused on. We're looking at how cells harness information, whether they care about information, whether they optimize for it. We use techniques such as fluorescence microscopy and microfluidics in order to create a simulated environment for our cells where we can then measure their internal responses to whatever we send them. And this allows us to understand the information processes that are going on inside of these bacteria. There are more cells in one human body than there are stars and planets in our galaxy. However, unlike our galaxy, which is the epitome of a constantly increasing entropy, a constantly churning chaos, cells keep their entropy low. They keep themselves organized. They keep themselves calm. I owe a lot of things to science, but right at the top of that list has to be the sense of calm which this piece of art and this realization has given me. Thank you very much.